Now take a multimeter and check for the continuity, like check its presence or absence of continuity in your breadboard's power rails. I believe Monica spoke about this continuity checking in multimeter. So I will check the continuity in your breadboard. Right now, I don't have a multimeter. That's why I'm not showing any demo. But still, if you have any doubt, you can just contact me later. So providing power to a breadboard. When it comes to providing power to a breadboard, there are numerous options. But I'll just speak about how it borrows from other power sources. I'll just focus on this cause நம்ம build பண்ற bot-க்கு mostly we will use this method. If you're working with any development board, no, for example Arduino, you can simply pull the power from the Arduino. The Arduino has multiple power and ground pins, which you can connect to the power rails or other rows in a breadboard. For example, in the photo here, the ground pin from an Arduino is connected to a row, and now if any component like resistor or capacitor is connected to that row, then all these will be connected to the ground. So the breadboard use பண்றதுக்கு சில tips and tricks வச்சுக்கோங்க. So always try to use very few wirings, because the breadboard should be used to make the majority of connections between the components. And moreover, it just adds on to the complexity of the circuit, and it will also end up like a wire wrap technique again. And the wires that you use, no, keep it as short as possible. Don't use big decoration stuff, because it just becomes a jumble of wires, and it will become more difficult to find the error, if any. And when you're building a circuit, and if a circuit model is given, just try to follow that, because at the end of the day, if there's any error, it will be very difficult to find out your errors. In the last class, it's from personal experience. And when you're cutting the components, no, and components and wires cut panabo, try to cut it with to a manageable length. If you feel that you're missing out on something, you know, if you're not able to find out an error, just call someone to help you. Okay, and ego la vaana help vaangradhu thappe illa, exam la kadai. So when you're working with these ICs, always place it in the middle of the breadboard. Again, when you're removing the components, be careful, especially when you're removing the IC chip. No, use a thin screwdriver, put it down to the ribbon, and carefully bring it up. ரெண்டு சைட்லயும் பண்ணணும்னு, ஏன்னா to avoid the bending of these pins by accident. So if wiring, there are a lot of little connections inside the breadboard, but it is in a fixed row. So basically, each pin or wire of a component have totally 5 connection points. To wire up all the parts that you have added on your breadboard, we need to wire the parts. So wiring is important. So நம்ம யூஸ் பண்ண, so the majorly நம்ம யூஸ் பண்ண போற 2 types of wires are jumper wires and solid core wires. And if you take a jumper wire, there will be a male to male, female to female, and a male to female wire. But நம்ம இப்ப பார்க்க போறது is just a solid core wires. So நான் சொன்னேன் இல்லையா இந்த ஸ்ட்ரிப் பண்றதெல்லாம் எப்படின்னு. Take a wire that you want to strip. With a basic calculation, just try to cut only half or 1 centimeter of the plastic covering at one end. Then cut the other side of the wire, and again, you cut just half or 1 centimeter of the plastic covering. But on the சொன்ன half centimeter or 1 centimeter சொல்றதுலாம், it's not a standard measurement. Basically, when you're connecting a wire to a breadboard, that is, when you're inserting the wire into a hole, the metal part correctly உள்ள போகும். Okay. And after inserting the wire, if you have some extra metal being exposed, then it means you have extra plastic cover எடுத்திருக்க. And after inserting the wire, if some plastic part also goes into the breadboard hole, means that you kammiயான plastic cover எடுத்திருக்க. So one sec. Okay, நான் சொன்னேன் இப்போ suppose if I have cover extra one plastic cover எடுத்திருக்கேன், I have stripped it off extra na, when you connect, no, you have a metal part sticking out. That's not good. And if suppose கம்மியா எடுத்திருக்கேன், கம்மியா metal கம்மியா plastic cover எடுத்திருக்கேனா, when you connect it, no, it's not completely connected, plastic part உள்ள போகுது. Again, that's not a good one. This is something which I did stripped off like half centimeter கணக்குல வச்சு. Like it's perfectly connected, and extra plastic covering உள்ள போல or extra metal partum வெளில வரல. That is something you have to follow. So ஒரு சின்ன tip. Well, ஏன் நாங்க வந்து solid core wire யூஸ் பண்ணோம், அந்த standard core இல்லனா, because easily the thread or strands of wire will unravel. அப்புறம் இந்த shorting that எல்லாமே நடக்கும். Okay. So that's why we are saying use solid core wires. ஒரு சின்ன tip. Well, as I said, the 2 sets of rails, no, power rails are not internally connected. That is, the left hand side and the right hand side power rails are not connected. Personally, I want these to be connected because the connections will be really easy. So try to do this. And also, when you get a breadboard and a set of wires, just try this at home. It will give you a good practice on how to strip and connect these wires. So that's it. That's all about this breadboard and wires. So actually, I saw the feedback for the previous sessions, and I saw a suggestion like by one of you. It was like, நாங்க பண்ண ப்ராஜெக்ட் வச்சு நாங்க எடுக்கிற டாபிக் எக்ஸ்பிளைன் பண்ணா நல்லா இருக்கும். Great suggestion. I really liked it. So that's what we are going to do. This is first one. This is an animatronic hand, a wired one. Pretty simple. The Kenvin Akhilesh தெரியும் நினைக்கிறேன். Pretty simple. I did it during the semester leave for first year. So just see the video. I'll then explain it. So the video வந்துச்சுல, can someone unmute and say that?
வந்துச்சுனா.
Okay. So this is an animatronic hand, a pretty basic one. Basically, it's a design of the robotic hand that works under the information that are received from the glove hand. It is using a flex sensor. Basically, the data is received from the flex sensor and it is sent to the servo motor, and the motor rotates to a required angle. An angle we can specify in our code. In the movement எல்லாம் ஒரு string வச்சு பண்ண. So in the glove இருக்கிற flex sensor as a blend பண்ணும்போது there will be a change in the resistance, and we process this using the Arduino, and we will send it to the servo motor. And our value we change it with the servo motor, and the servo motor rotates and strings வச்சு the hands move. So the Arduino is the interface between the servo motor and the flex sensor here. Last our voltage divider வச்சு we reduce the voltage. So the reduced voltage we provide it to the flex sensor because that requires very small voltage. So if here நான் சொன்ன the resistor, voltage divider, interface, Arduino, servo motor connections கொடுக்கிறோம் through wires. So இதுக்கு கரெக்டான wiring is really important. And in the connections base is breadboard. So இதுல தெரிஞ்சிருக்கும் breadboard and wiring are importance. So this is another project. And one another. Okay, so this is an obstacle. First was an obstacle follower, and next is an obstacle avoider robot. I did it during this lockdown. Simple wheels and the components. So basically, as the name goes, one follows the object while the other avoids the object. So here I have used an object sensor. It senses if an object is there or not. Simple. It sends the data to the motors and motor driver to rotate the wheel and to travel in a certain direction accordingly. Again, it also involves resistance, voltage divider, etc., etc. Again, the Arduino is the interface between the motor driver, and the sensors. It's ரெண்டுமே different projects now. You just make some minor changes in the code. Again, the voltage divider, resistance, motor driver, motor, sensor, எல்லாமே wires வச்சு connect பண்ணனும். And இதுக்கெல்லாம் base again the breadboard. So the line follower which you will be doing in the due course also is very similar to this, except you will be using IR sensors, and we'll change the code altogether. So that's it. I hope I've given you some insight on breadboards and wiring. I mean, எல்லாமே சொல்லிட்டேன்னு சொல்ல மாட்டேன். And I'm sorry, like டக்குன்னு இந்த செஷன் முடிக்க வேண்டியதா இருக்கு. I'm like கொஞ்சம் ரொம்ப throat problem and fever இதனால I had to cut short the episode. So if you have any questions, you can just ask me.
Bro, the power rails இருக்கு actually
சொல்றா.
பவர் ரெயில்ஸ் வந்து மெயினா கிரவுண்டிங்க்கு யூஸ் பண்ணுவாங்களா இல்ல அதோட ஆக்சுவல் பர்பஸ் வந்து இன்னும் கொஞ்சம் கிளியரா எக்ஸ்பிளைன் பண்ணுவீங்களா?
Power rails, okay, cool. One second.
அதை கிரவுண்டிங்காக யூஸ் பண்ணுவாங்க. இல்லை நான் கிளாஸ்ல பிரெட் போர்டு வச்சு நம்ம சர்க்கியூட்ஸ் கிரியேட் பண்ணும்போது கிரவுண்டிங் தான் யூஸ் பண்ணுவோம்னு ஒரு தடவை ஃபேக்கல்ட்டி சொன்னாங்க. பட்
கிரவுண்டிங் மட்டும் இல்ல, லைக் இப்போ நீங்க இந்த காம்பனன்ஸ் ஆக்டிவேட் பண்ணணும்ல, இப்போ நீ ரெசிஸ்டன்ஸ் ஒரு வோல்டேஜ் வேறெல்லாம் ஆக்டிவேட் பண்ணணும், அது ஒர்க் பண்ண வைக்கணும்ல.
ஸோ ஆக்டிவேஷன் பண்ண பவர் ரைட்ஸ் யூஸ் பண்ணுவாங்க.
பவர் ரைட்ஸ் அது அண்ட் மெயினா கிரவுண்ட் கனெக்ஷன் கொடுக்கறதுக்கும்.
ஓகே
ஓகே. வேற ஸோ ஓகே, இப்போ கேட்க வந்ததுன்னா யூ கேன் ஜஸ்ட் மெசேஜ் மீ, ஐ வில் ஹெல்ப் யூ அவுட் தேர். அண்ட் இன்னொரு ஃபீட்பேக்கும் படித்தேன், லைக் போன இதுலயே லைக் ரொம்ப டெக்னிக்கல் டேர்ம்ஸாக இருக்கு, கொஞ்சம் கஷ்டமா இருக்குன்னா. டோன்ட் வரி, எனக்கு அப்படிதான் இருந்துச்சு. கொஞ்ச நாள்ல யூ வில் பி டார்மரா அந்த வேர்ட்ஸ் எல்லாம் யூ வில் ஆல்சோ யூஸ். ஸோ ஐ ஆல்சோ அட்டாச் அ ஃபீட்பேக் ஃபார்ம் த சாட் பாக்ஸ், ஃபில் பண்ணுங்க.